Good morning everyone. I am Dr. Susmitha, Assistant Professor of Civil Engineering Department, G. Pullareddy Engineering College, Kurnool. So today I am going to deal Railway Engineering, that is Module 2 of Multimodal Transportation Engineering. So today's presentation covers the following contents: permanent way, gauge length, functions and requirements of rails, types of rail sections, various defects in rails. So first let us see what is meant by a permanent way. So a permanent way is nothing but railway track of permanent nature, or otherwise we call it as a permanent way is a combination of rails fitted on sleepers and resting on ballast and subgrade. So the main purpose of providing this permanent way is to provide a permanent facility for safe and quick movement of trains which are moving in between starting and destination stations. So the component parts of permanent way are formation of subgrade, ballast, sleepers, rails, fixtures and fastenings. So you can observe all these component parts in this cross section of permanent way. So here rails, ballast shoulder, sleepers, okay, horizontal members in the railway track are called sleepers, side slopes how they are providing 1.5:1 and for formation width it is 2:1. Okay, so then you can see how the ballast is packed in this cross section. So here you can see a new term, that is gauge length. So gauge length is nothing but inner to inner distance between two successive rails. So in permanent way, rails are joined in series by using fish plates and bolts, and then they are fixed to sleepers by using different types of fastenings. So sleepers are the horizontal members which must be properly spaced and they must be resting on ballast and must be suitably packed with ballast material. So the layer of the ballast which is resting on the prepared subgrade is called formation. The rails which acts as girders to transmit the wheel load to the sleepers, underlying sleepers. So the main function of the sleeper is to hold both the rails together in the position, okay, when heavy loads are coming from the fast moving train. So the ballast material, it distributes the load over the formation and it holds both the sleepers in the position. So you can see this is a permanent way. So where you can see horizontal members are the sleepers, okay, so rail sections and then ballast packing over formation, overall formation width you can observe in this figure. So next is requirements of an ideal permanent way. So what are the basic requirements of the ideal permanent way which we are providing for the movement of the rails? So we have seen gauge length, that is inner to inner distance between two successive rails. That gauge length must be same, it must be correct and uniform throughout the railway track. So rails should be at proper level. So whenever you are using a straight track, both the rails must be at the same level. In the case of a horizontal curve, you need to provide super elevation on the outer rail properly. So alignment, the center line position must be correct. Gradient should be uniform. Whenever there is change in the gradient, you must provide a smooth vertical curve for smooth passage of train. So tractive resistance of the track must be minimum. Track should possess sufficient elasticity and it must be strong against any type of lateral forces. The radius and super elevation, in case of horizontal curves, it must be properly designed and maintained, otherwise overturning will happen at horizontal curves. So the side drains and drainage system of the track must be uniform. So that is, in order to maintain a good drainage system in a railway track, you need to provide a good ballast material. Okay, so it must be free from excessive joints. So if you take any structure, joints are the weakest points in that structure. Okay, so avoid excessive joints and use minimum joints as possible. all components of the track should fully satisfy the requirements for which they have been provided in the track. There should be adequate provision for easy renewals and repairs of any portion of the track. The track structure should be strong. Initial cost, maintenance cost, operation cost, so overall cost must be as minimum as possible. So next we will see what is meant by a gauge length and what are gauges in India and around the country. So we have seen the distance between inner faces of any two pairs of the rails is called gauge length. So in India, we are using mainly 4 types of gauges, that is standard gauge, which is also called as broad gauge, meter gauge, narrow gauge, feeder gauge or light gauge. So these are the 4 types of gauges which we in general use in our country. So what is meant by this broad gauge? So whenever the clear distance between any two successive inner faces of the rails is 1.676 meters, we call it as a broad gauge. Okay, so it is also known as standard gauge. Next, meter gauge. So if the horizontal distance between inner faces of two rails is 1 meter, then the gauge is called as meter gauge. So next we have narrow gauge. When the clear distance between inner faces of the rails is 0.762 meters, then this gauge is called narrow gauge. So this type of gauge is mainly used in hilly areas, so where the traffic volume is very low. Next is lighter gauge. So whenever the clear distance between inner faces of the rails is 0.610 meters, we call it as a light gauge. Okay, so these are different types of gauges which we use in general in our country. So next, so what are different types of gauges adopted in different foreign countries? Okay, so here it is given as UK, USA, Canada, Europe, France, Switzerland, okay, Japan, and different types of in different foreign countries they use different types of gauges, that is standard gauge, meter gauge, narrow gauge, and the corresponding gauge length is given in this slide. So how to select a gauge? Based on what factors you need to select the gauge? So first point is cost of construction. Okay, so cost of construction increases as the gauge width increases. Okay, so there is little increase in the initial cost when we select a broad gauge. So this is due to the following reasons: cost of bridges, tunnels, station buildings, staff quarters, signals, cabins and level crossings is same for all the gauges. So cost of earthwork, ballast, sleepers, rails is same, which are proportionally increases with increase in the gauge length, and there is a little proportional increase in the acquisition of land for the permanent track if you increase the gauge length. Next point you need to consider while selecting the gauge is volume and nature of the traffic. Okay, so whenever there is higher volume or more number of trains are moving in between origin and destination, then you need to go for broad gauge when compared to the light gauge. Okay, so light gauge is provided whenever there is a low traffic or the frequency of the trains is very less. Next, development of the area. Narrow gauges can be used to develop thinly populated areas by joining the underdeveloped areas with developed or urbanized areas. Next factor is physical features of the country. So in general, in hilly regions we select narrow gauge, and in whenever high speed is not required and traffic is light and even it is plain area, we go for narrow gauge, which is a right choice. Next factor which you need to consider is speed of the movement. The speed of the train is proportional to the gauge. Almost it is directly proportional to gauge. So the diameter of the wheel in general it is 0.7 times the gauge. So lower speed discourages the customers to maintain the high speeds and broad gauge is preferred. So next we have seen different component parts of typical cross section of permanent way. So in that rails are the main component which acts as girders to transmit the load which is coming from the rail wheels to the underlying sleepers. So what are the functions of these rails? So the main function of this rails is to transmit the load to the underlying sleepers. And there are some other functions. It must provide a hard, smooth and unchanging surface for the passage of heavy and fast moving trains. So these rails must bear the stresses which are induced due to vertical loads as well as lateral forces, braking forces and thermal stresses. It must give minimum wear, okay, so and it must transmit the load to the underlying sleepers. So these are the 4 functions of the rails. So for any rail section must consist of following composition of components. So here you can see carbon content, manganese, silica, sulfur, phosphorus. Okay, so the contents may the content range may vary, but they use only these elements in the preparation of the rail section. So for ordinary rails it is different, and for points and crossings the composition may be somewhat different, lightly different. So what are the requirements of these rails? The rail section should be proper, it must compose of proper composition of the steel. So just now we have seen the different composition of different materials. So all these components must include in the rail section, and it must be manufactured by using open hearth and duplex process. So vertical stiffness of the rail section must be high enough to transmit the load to the sleepers. That is, height of the rail section should be adequate. Okay, so it must be capable of withstanding the lateral forces. The head must be sufficiently deep to allow adequate margin of vertical wear. So web must be sufficiently thick in order to take the loads which are coming laterally. Okay, so foot must be sufficiently wide. If the foot is not wide, then overturning will happen, especially on horizontal curves. So bottom, head, top of the foot should be, the shape must be prepared such that it must enable the fish plates to transmit the vertical load efficiently from the head to the foot at the rail joints. So relative distribution of the composition of materials in head, web and foot must be balanced. Okay. Center of gravity of the rail section must lie approximately at mid height, so that it will bear tensile and compressive stresses, and they both must be equal. The fillet radii must be large in order to reduce the concentric stresses and tensile strength of the rail section. The rail specimen should withstand the blow of falling weight test and tup test. Okay, so these both tests you need to conduct in the laboratory before that you are going to use in the railways. So what are different types of rail sections which we use in general in the permanent way? Okay, we have mainly 3 types: double-headed rails, bull-headed rails and flat-footed rails. So here you can see in this diagram. So double-headed rails are the rails in which both head and foot will be in the same size and shape. So in case of bull-headed rails, the head will be larger when compared to the foot. Okay. In case of flat-footed rails, foot will be larger when compared to the head. Okay, so the both is the same is given in these slides. So next topic is various defects in rails. So what are different types of rail failures that in general occurs? So we have different types of rail failures, that is corrugated or roaring rails, hogged rails, kinks in rails, buckling of rails, wear on top and creep of the rails. Let us see what is one by one in briefly. Okay, so what is meant by a corrugated or roaring rail? So corrugations are nothing but undulations or minute depressions which occurs on the surface of the rails. Okay, so whenever a rail passes over such type of uneven or undulated rail sections, a roaring sound will be created which is intense enough to be unpleasant. Corrugated rails are in general peculiar in nature, they are peculiar in occurrence and peculiar in the real cause. So the remedial measure for this corrugated or roaring rails is simply grinding the rail head. So here you can observe in this figure the uneven rail section which is grinding by the grinding machine in order to smoothen it. So next type of failure is hogging. So this type of hogging occurs in general at the ends of the two successive rail sections. Okay, so that is nothing but hogging is nothing but deflection at the ends of the rail section. Okay, so the remedial measure is you can crop it. Okay, either you can crop it, so both the hogged rails can be cut off, okay, and fresh holes will be made, and both the rail sections will be attached by using new fish plate and bolt. So this cutting may be either done in the workshop or at the site, and after cutting this defective end, the rails must be pulled back together in the position, and it is very common method in the advanced countries. So next remedial measure for hogging is replacing. Okay, so you can completely replace the hogged rail with a new one, and it is very uneconomical method. So next is welding. So you can do welding in the field, and you can straighten the hogged portion, and you can again connect the rail sections. Next is dehogging. So it consists of a straightening the end by means of dehogging machine. So here you can observe what is meant by hogging. It is nothing but a deflection at the ends of the two rail sections. So next type of failure is kinks in rails. Kink is nothing but a slight deflection in the railway section, that is a slight movement you can observe which is out of the portion. So here in this rail section you can observe a slight movement or slight deviation of the rail section occurred, that is nothing but kink. So the causes for these kinks may be loose packing of fish plates, defects in gauges and alignments, uneven wear in rail head, defects in cross levels at joints. So next failure is buckling. So this is same as kink, but buckling is nothing but it is completely the rail section has gone completely out of its original position. So you can observe here the intensity of the deviation will be more when compared to the kink in case of the deflection. So the causes for this buckling is insufficient expansion gap, fish plates may not be tightened properly or may be tightened so tight so as to not allow it to expand during temperature changes, and it may be due to presence of longer welded joints, it may be due to insufficient ballast and sleeper density, improper application of lubrication oil, fixing of anchoring, fish plates and fastenings. So next, damaged rails. The damaged rail is nothing but it is completely damaged. So the main remedial measure for this is you can completely remove the rail section and replace with a new one. Okay. So causes are wear of rails, defects due to manufacture, defects of hogging in excess, and it may be due to damage caused to the rails. So wear is nothing but it is very prominent in the rail sections. It is nothing but warning out of the head of the rail section. So it generally happens in case of where at the points where the rail section in general more brakes will be applied by the train. So allowable limits are in general prescribed limit of the wear is 5% and it is allowed up to 8% also. So there are some methods to reduce the wear. So whenever it exceeds its permissible or prescribed limit, that is 5%, the rail section must be completely replaced. Otherwise the train will slip out of its position. Next, if you can use special alloy steel in order to reduce the amount of the wear. Regular tightening of fish plates and packing of ballast, which is necessary to reduce the wear. Reduction in number of joints. So if you reduce the number of joints, then also you can reduce the wear. Welding or dehogging of battered ends in time will also reduce the wear. Track maintenance, maintenance of joints, maintenance of correct gauge will also reduce the wear. So last type of the failure is creep fail. So creep is in general, it is called as longitudinal movement of the rail in the track in the direction of motion of the locomotive. So the main causes for this creep may be, it may be developed due to forces which are coming into operation when the train is starting or stopping by the application of the brakes. When the wheels of the vehicle strikes the crest due to wave motion, creep will develop. So, due to unequal expansion and contraction of temperature changes, also creep will develop. So, the minor causes are given here when the rails are not properly fixed to sleepers properly. Okay, so bad drainage, bad quality of sleepers, improper consolidation of formation, gauge, if the gauge is fixed too tight and it is not allowed to move freely due to temperature changes, then also creep occurs. Incorrect adjustment of super elevation at outer rails, incorrect allowance of rail expansion, rail joints maintained in the bad condition, all these are the minor causes of the creep. Thank you.